All right, welcome back. Thanks for coming. And this is module 6.6, expressions containing several radical terms, in which we're going to talk about adding, multiplying, and rationalizing expressions that have more than one radical term in them. So we'll start by adding. If I have something, say, like 3 square roots of 2 plus 4 square roots of 2, right? We're going to treat it just like we did with variables. So recall, if I have 5x plus 9x, right? What I'm really going to do is undistribute that x, and I'm going to pull the x's out and say these x's are out here, and what's left is 5 plus 9. And if what's left can add together, 5 plus 9, that gives me 14, times x, that's 14x. The same thing happens here. I've got a square root of 2. I've got a square root of 2 in that term. I'll pull that out as a square root of 2. And what's left, and I pull it off to the right. You can pull it off to the left if you want. But what's left is 3 plus 4. I can add those because they're just whole numbers. 3 plus 4 is 7, root 2. So I can add, the moral of the story is that I can add essentially like terms if you treat a radical of whatever's under it as kind of a term, right? For example, if I had 3 square roots of 3 plus 2 square roots of 2, I can't do anything with that. I cannot simplify. Because they don't have the same square root. One has a square root of 3, one has a square root of 2. That's not going to simplify. That's it. I just leave it just as though it were something like 3y plus 2x. I can't combine those. I just leave it in that sum. Okay. If I have 6 times the 5th root of 4x plus 3 times the, oh, sorry, my bad. Oh, don't do that. 3 times the 5th root of 4x minus the cube root of 4x, right? I've got these two terms that are the 5th root of 4x. These are like terms. I can combine these guys. But this guy with that 3rd root, right? He's the odd man out. I can't do anything with that guy. He's got the wrong index. Even though it's 4x under the root, it's got the wrong index. It's not the same term, right? I can't simplify that particular term. But I can add these two. I've got 6 plus 3 more. That's 9. 5th roots of 4x. But I've got this minus cube root of 4x that I cannot do anything with. I can't combine it. Don't try to combine it. It doesn't combine. It just has to stay just like that. That's it. Done. If I have, say, 3 times the square root of 8 minus 5 times the square root of 2, can I do anything with that? Well, the answer is no, but no, not yet, right? Because 8 can be simplified. The square root of 8, if I look at that like the square root of 2 times 2 times 2, which is 8, oh, I can pull out 2. Yoink. And when I pull out that 2, it multiplies, right? I'm going to pull out a 2. The 2 gets multiplied by whatever's out there. So that is now a 6. What's left is that one last 2. So it's 6 times the square root of 2 minus 5 times the square root of 2. Now they're the same type of terms. So they're root 2 terms. I can take 6 minus 5. That's 1. So I'm just left with 1 square root of 2, or just the square root of 2. And that's it. Done. Easy. So let's take a look at this one. If I've got the cube root of 2x to the 6th, y to the 4th, and plus 7 cube roots of 2y. Can I add them? I don't know. I can't do it right now. I can't do it like this, but I'm going to simplify them to see if I can. I'm under a cube root, so this x to the 6 is 2 pairs of 3 x's, so that comes out as x squared. Y to the 4th is 2 pairs of, there's one pair of, one triplet. There's one group of 3 y's, and so that comes out as a y. And under that cube root, what didn't come out is that 2 and one of those y's. But I still really can't combine these much because I have an x squared and a y in the first term, and I don't have those in the second term. But if I still think of this as that kind of reverse distribution or factoring, right? I can pull the 2y under the cube root out, and that leaves me with x squared y plus 7. And that's about the best that I can do, right? I can't really combine these any further, so this then is as good as that simplification process gets. Now, if I want to multiply, let's say I have the square root of x, and I'm multiplying that by x minus the square root of 2. Right? This is the same as distributing when we were talking about polynomials. I can take this square root of x and multiply it by the x, and that would just be x. I'll write the x first. Anything that's not as a square root, I'll write first. Multiplied by the square root of x minus, and this becomes the square root of x multiplied by the square root of 2, but I can combine those. If I have the square root of something multiplied by the square root of something else, I can combine that into 1 square root of x times 2, or 2x. And I can't combine anything else. This is it. I'm done. If I'm going faster, I'm just kind of going through this material. I don't have an audience, so I'm not gauging how fast anyone's going. But if I go too fast, hit that pause button, write down your material, and then unpause it and move on. So next, let's say I have the square root of 3 plus the square root of y, and I square that whole thing. Now this is a binomial that gets squared, so what that means is that binomial, square root of 3 plus the square root of y, multiplied by the square root of 3 plus the square root of y. And now, as you can imagine, I'm going to FOIL these together. The square root of 3 times the square root of 3 is 3, because that's the square root of 9, right? So that's 3. But I have the square root of 3 times the square root of y, so that's the square root of 3y. And then I have root y times root 3, which is also the square root of 3y. And then the last one, the square root of y times the square root of y, that is just y. And these middle two terms, they're the same. There's one square root of 3y, another square root of 3y, so that is then 2 square roots of 3y. Plus y on the right, and then plus that 3 on the left, and that's as much as I can simplify it. Okay. Now, one of the interesting things that happens here is if I have, say, the square root of a minus the square root of b, and I multiply that by the square root of a and change it to a plus the square root of b, I'm going to FOIL that together just like I just did. So I get the square root of a times the square root of a is an a. The square root of a times the square root of b is plus the square root of ab. But this term here is minus square root of b times the square root of a, which is minus then the square root of ba or ab. I'll write it as ab. And then minus the square root of b times the square root of b, which is minus b. These two terms cancel out because they're the same but opposite sign, and I end up with a minus b. You might recognize this as a special case of the difference of two squares, where instead of squares, they're just a's and b's, right? But what's interesting about this is we started with irrational, 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 or potentially irrational, right? If a and b are rational numbers, these guys are all potentially irrational, but I multiply them together and I got a rational number. Which is great because the next thing that we're going to talk about is how in the world do we rationalize a denominator that looks like this, right? But we just saw it. If I take the square root of x plus 2 and I multiply it by the square root of x minus 2, I'm just going to change that sign. If it's a plus, I'm going to multiply it by a minus. If it's a minus, I'm going to multiply it by a plus. So that's what I'll do. If I want to rationalize this, I multiply the bottom by the square root of x minus the square root of 2, and the top by the square root of x minus the square root of 2. So let's FOIL those together. Well, in the top, it's just a distribution, so that becomes 2 times the square root of x minus 2 times the square root of 2. And in the denominator, when I multiply this out, the square root of x times the square root of x is just x. The square root of x times minus square root of 2 is minus the square root of 2x. Then I get plus the square root of 2x. Hey boy, hang on just 1 second, okay? Okay. And then plus 2 times minus root 2 gives me minus 2. But again, we see these two terms right here, the minus root 2x, the plus root 2x, they cancel out because one's minus, one's plus. And in my denominator, I end up with just this x minus 2. There's no more square roots. It's gone. It's rationalized. And in the numerator, it's okay that we have those radicals because we're more interested in having a rational denominator than we are having a rational numerator. And it's been rationalized. All right. And that's it for this one. That's the material of this section. So I'll cut this here and pick it up on 6.7. Thanks. Bye.